In this video, we're going to run through the case study for a demonstration program for a motorcycle tour system using SSADM and UML techniques. Exploring a variety of these different techniques will enable us to find a suitable system to help combine the people using the system, the information technology used, and most importantly, the business or company's objectives. Creating a mind map is a great starting place for use case studies, as it allows us to visually represent how we initially understand the system from the use case study. The mind map has a key concept of system, which is centered, with also other subsections that branch off, such as staff, booking, and tour. These subsections expand further by having their own individual assets, such as customer containing customer details and general inquiries. Relationships have been identified and labelled between each of the entities, such as booking relates to tour and that staff interacts with the system. The same principles have been applied for a system diagram as they have been for the previous mind map, but focuses on the initial understanding of the company, in this case the motorcycle dealership, which is centred in green. Being able to identify actors of the system creates a more in-depth understanding of how the system will function. Although customer does not directly interact with the system itself, the use case states that the staff are to handle telephone inquiries on behalf of the customer. Therefore, meaning customer is an actor as well as staff, however just a secondary actor. The external payment is also an actor of the system, as it will need to interact with the system in order to complete the payment process for a customer booking. Following on from a system diagram, a context diagram goes more into depth on understanding the entities in their environment, components used, and the data flowing in, out, and in between one another. Different entities have been identified as being interactive with the system, such as the staff, external payment system, and customer. As previously stated before, the customer doesn't directly interact with the system, but acts through by the members of staff. Company is an entity to consider within the environment, but does not use the system. Components within the system are labelled Maintain Details, Tour Info, and Booking. Maintain Details refers to view, add, edit, or delete any types of data within the system. Data flows are represented between actors and components by arrows showing data coming in from staff and out by booking to the external payment system. All the components are within the boundary, and only the staff interacts with the system through the interface on the border of the system boundary. It may be important to note that also all actors are outside the system within their environment. Following on from the context diagram, a data flow diagram for this case study has been identified as having the data stores of customer, bookings, tour info, legal, and feedback. Arrows labelled view, update, add that are pointing towards the data stores from the processes should have arrows pointing back towards them, showing the data flow between the two. However, the diagram would have been extremely clustered, and that's the reason for them not being added. Processes have been also identified and have been assigned to the appropriate entities that would use them for certain tasks. For example, staff, at the bottom left-hand side of the diagram, would perform the task of viewing a specific customer's details by executing the process of maintaining information. This process can then access the relevant data stores needed in order to gain the information desired by the actor of the system to then relay back to the customer. Finding the different data stores from the DFD leads on to being able to create an entity matrix to reinforce how the system will be designed and developed. The different entities used in the entity matrix have been taken and slightly amended from the data stores that were created in the DFD. From here we can try and gain some understanding and shed some light on which of these entities are related and how they're related. Examples of relationships between different entities shown in the entity matrix can be shown as tour information linking to booking information. Customer information does not directly link with tour information, as realistically each customer needs to have a booking, and therefore booking is the entity that is related to tour information. Tour information is also related to legal requirements, as these have a direct relationship, as the legal requirements could change depending on which tour it is. Using the entity relationship matrix allows us to clearly define what entities will be used within our entity relationship diagram. As we've seen from the previous slide, some of these entities are related, and this can be shown using an EID by the whether or not they have joins and the type of joins that they use. Following on from the previous example, if we look at the customer entity, we can see that its unique identifier is the customer ID, or CUST ID for short. A customer may be attending a tour, but in order to attend a tour, the customer must first have a booking which specifically relates to a specific tour. This is done within the booking table as a composition key that intakes the values from customer ID and tour ID. These two foreign keys make up the table's primary key for booking, allowing a unique identifier when finding a specific booking for a tour for a certain customer. An additional foreign key for passenger has been included, but this is not essential, as a customer does not necessarily have to have a passenger to book a tour. This foreign key just identifies a unique passenger that's related to a tour if applicable. The next step after creating an entity relationship diagram is to create an entity life history diagram for each entity to represent the data's lifespan from the time it was created, when it gets modified, and by what events, and the deletion or archiving, in this case, of its data. The ELH shows both customer and booking and the processes involved. Below each event, state indicators have been labelled to show what stage of its lifetime these events can occur. Null events happen early on in the creation of the customer if the customer does not exist. A series of optional events also occur in this event, and the booking diagram for whether or not a passenger is required. Iteration has been included for editing customer details, as this stage could potentially be repeated numerous amounts of times, similar to changing booking details. The midlife state of the booking shows parallel life between life and changes, as the information updated in life automatically becomes updated for changes in change booking details. Okay, so moving now on to more UML techniques, this mind map shows a 3 and 4 tier branch approach to visually represent who, why and when in relation to the system. A variety of different concepts have been taken into consideration, and not just the actors of the system such as staff and customers. Tours and feedback are also relevant when looking at mind maps, as they contain various different aspects relating to the use case that are important, such as what type of tour it is. Could it be a UK tour or a abroad tour, as well as feedback relating to that tour. All possibilities need to be taken into account for who is using the system, therefore this is the reasoning for adding the external payment system to the mind map. Why can be expressed simply by staff wanting to maintain information within the system, such as editing customer details or tour details. Staff can also be included within when, as the staff will only want to interact with the system if they're looking for customer enquiries or making amendments to the data within the system. A full list of use cases has been provided within the support and evidence file that has been attached on my course, but for this presentation only, the booking and gather feedback have been used alongside their expanded use case that gives a deeper understanding of the process and requirements that may be involved. Separately written user stories for both use cases have also been included in the support and evidence file that shows a conversational style approach. The booking use case clearly states it's a primary use case, its primary and secondary actors and prerequisites of customer and passenger details if applicable. The if applicable has been included as the customer would provide customer details in order to make a booking and therefore would have to go through further steps in order to make a booking. The use case of gather feedback adopts similar principles in regards to its level, essentiality and its primary and secondary actors. Prerequisites state the customer must have booked and attended a tour. Both requirements have been included, as otherwise the possibility could exist that a customer has booked a tour and then cancelled that tour, but yet is still asked for feedback about that specific tour even though they did not attend. This could potentially be done by checking whether the customer has a booking, did not cancel that specific booking, and the date is shortly after the attended date of the tour. The domain model diagram expresses how each entity relates to one another in order to function correctly. All categories have been previously identified, and a list of all of their attributes and classes have been listed. The key in the top right hand corner indicates which is an attribute and which is class, and also have been color coded. Certain aspects of the domain model can be used to interpret a more complex understanding of the system, as shown by examples of the relationship between booking and tour. This certain relationship is a composition, as bookings would not exist without the entity of tour. Examples of aggregation can be seen by the relationship of customer and booking, as a customer can still exist as it has everything it needs to stand alone as an entity without booking. Once all the use case and user stories have been listed and actioned, a general or overview use case diagram can be created to visually represent which specific actors of the system interact with the entities of the system. In this diagram, we can see that staff is related to all of these entities within the system, but on the other hand, the customer has relations with all except view, add, update, maintain, and process feedback. Indulging further into use case diagrams, the following screen shows two expanded use case diagrams for booking and feedback. On the left hand side we have the booking expanded use case diagram, and starts off with a customer calling the dealership. Then they're put through to the member of staff who handles their booking request by the process of choose tour. It's important to note that for this particular diagram we are making the assumption that the customer is already a registered customer, meaning all their details are on the system and their identity as the caller they say they are has been confirmed by the member of staff over the phone prior to this. Book tour then comes into action where it could become one of either two states, available or fully booked. The path for fully booked allows the staff member operating the system to revert back to the previous process to choose tour if the customer wishes to potentially book another tour, or simply the use case may end at this point. If the tour is available to book, then the option for availability becomes present and allows one of three options: booked with an unconfirmed place, deposit paid, also securing a place, or fully paid and fully secured place. However, the deposit and fully paid are both relating to an external payment system, and therefore the use case would end here. Outlining the main steps in the extended use case diagrams enables us to create a robustness diagram to further explore the exact steps that would be involved for booking tour or receiving feedback. Actors of the system are clearly represented by the stick figure and labelled staff and customer for booking, and just staff for feedback. Although the customer does not interact with the system for both, I think it's important to identify in the booking that the customer is actively involved in the initial process, as this would not be possible if the customer did not ring to book. Entities, boundaries and controllers are included in both diagrams to create the different steps and scenarios that are involved. The feedback robustness diagram has been cut short by only displaying the actions that would occur for asking question 1. This is due to the presentation not being able to clearly fit. However, this process would just be repeated a further 4 times and follow on to the final step of save and return link, and then to customer feedback page. Within the state transition diagrams, we are looking at the following classes of view customer and cancel booking. Both of these examples show how each of the classes act and in what state they could potentially be leading on from the previous step. This not only tells us what step it leads on from, but also what step it cannot go to from the state it may be on at that moment in time. For example, on the right hand side example for feedback, after following the different stages of states, we can see it could potentially be on no record found. At this state, it cannot then go to the state of confirming the cancellation. However, it can go to its final state where it has ended, or refer back to the previous state of check customer bookings exists.